Assalamualaikum and hi, my name is Natasha Binti Jeffery and I will be explain my final year project about phytochemical screening analysis in Eleutherium bulbosa extracts and its potential as antibacterial and antioxidant activity, which supervised by Madam Shafinas Binti Abdullah. Eleutherium bulbosa, or known as bawang dayak, are mostly found in Amazon rainforest and some parts in Africa and Asia. The bark of bawang dayak is one of the traditional herbs that usually used as therapeutic potential to treat people. E. bulbosa does have variety of pharmacological activities such as anti-cancer, anti-diabetic and more. Top bioactive compounds in bawang dayak has been reported by Kamarudin in 2021 to be excelled in antimicrobial agent and as a natural antioxidant source. There are some problem statements in it. Firstly, bawang dayak were less introduced in Malaysia due to unknown in here. Second, due to increased use of commercial antibiotics in human and animal agriculture, tons of bacteria has been evolved towards resistance. Lastly, the disease like inflammation, aging are closely linked to the effects of oxidative stress in human health. There are 5 research questions in this disease. What are the suitable extraction for extract bawang dayak? What biocompounds present in E. bulbosa? What is the link between phytochemical test and antioxidant activity? What are the benefits of antioxidant agent in bawang dayak, and can E. bulbosa extract able to give zone inhibition in E. coli and B. lichen-uniformis? The significance of study are the flavonoids family were one of the natural oxidants found in E. bulbosa, which able to lower the risk of chronic illness, and bawang dayak frequently used in traditional medication as an antibacterial agent, and it also produce some commercial products like tea bags or anti-acne cream formulation. 3 objectives that could get in this disease, which are to identify the phytochemical constituent in E. bulbosa extract by using preliminary phytochemical screening analysis, to investigate the antibacterial activity by using this diffusion method, and to examine the antioxidant ability by using DPPH scavenging assay performance. For scopes, it will be able to explore the biocompounds in E. bulbosa ethanol extract by using maceration extraction method, and to investigate the antioxidant abilities and antibacterial activity. The initial process of producing crude by using solar percussion method would change due to insufficient time, and some methods in phytochemical screening were adjusted because of expiry date and unavailable chemical compounds in lab. A herbaceous Rhizotomus eleutherium genus tree does have red white tunics, several bitter bulbs which is almost similar to onions, crisp linear lanceolate leaves, and 5 to 6 petals of white pink flowers which opens in the evening and only winters in few hours. In 2021, Ardani stated that E. bulbosa ethanol extract does contain flavonoids, alkaloids, saponins and tannins, which are liable for antibacterial testing, phytochemical screening, and antioxidant activity. Flavonoids, which have general structure of 15 carbon skeleton and have 2 family rings and heterocyclic rings, function and inhibits the growth of bacteria, virus and fungi. Alkaloid, natural as organic nitrogen bases, function as they disrupt the components of peptidoglycan in bacterial cell death. Tannins, class of astringent, function as contracting the cell wall and disrupt the permeability of cell. Lastly, saponin, as terpene, glycoside, function as clearing agent and emulsifier. Antioxidants are molecules that store oxidant, which producing free radicals and trigger cascade reaction. It able to stabilize free radicals by giving electrons and producing scavenging free radicals, transform free radicals into compounds that are non-reactive. DPPH scavenging assay is one of the simple, quick, calorimetric method that evaluate the antioxidant properties of pure substance by using UV absorbance spectrometer at 517 nanometer. Antibacterial activity can be defined as activity which inhibits the growth of bacteria such as Escherichia coli or E. coli as gram-negative bacteria, and Bacillus lichen-uniformis or B. lichen-uniformis as gram-positive bacteria by using active agent to prevent the formation of microbial colonies. And this diffusion test is one of the sample technique. Gentamicin as positive control in antibacterial activity are one of the modern antibiotic drugs which usually treat skin disease. Padi in 2015 mentioned that bawang dayak extract from maceration extraction able to produce zone inhibition well in both E. coli and B. lichen-uniformis. For the extraction of Elythrine bulbosa, starting with collecting raw materials in Penang, washed with distilled water and dry cleaned. After that, the bawang daya are dried for 48 hours under 60 degrees Celsius in hot air oven. After the drying session, the bawang daya were ground into small pieces by using a blender and stored well. The powder was soaked into the 95% ethanol in 34 hours by using maceration extraction trials. All of the solution will undergo rotary evaporation for dryness, and lastly, bulbosa ethanolic extract crude will form, wave and store under 4 degrees Celsius freezer for next session. For preliminary phytochemical tests, there are 4 biocompounds that wanted to testify, which are Mayer test for flavonoid, Shinoda test for alkaloid, foam stable test for saponin, and tannin test. For DPPH free radical scavenging assays under antioxidant scavenging assay, it needs to prepare 3 stock solutions, which are bulbosa ethanolic extract, ascorbic acid, and 0.5 ml DPPH solution in 100 ml volumetric flask each. First, it needs to prepare 5 different concentrations of extract sample, 20, 40, 60, 80, and 100 mg per ml. Next, each 1 ml of the extract sample concentration was transferred to another 10 ml of volumetric flask, added 0.5 ml DPPH, and filled up with 95% of ethanol until it reached to the calibration marks. All of the extract sample were covered up with aluminum foil and stored in dark room for 30 minutes. All of the extract sample were taken out and transferred to cuvette and measured their absorbance by using UVB spectrometry in 517 nanometer trials. This procedure was repeated for the preparation of ascorbic acid. For antibacterial activity, starting with the preparation of MHA, 38 grams of MHA powder was suspended and added into 1 liter of distilled water, stirred and autoclave. Then, MHA solution poured into each agar plate and stored, followed by preparation of nutrient broth. 2.6 grams of MB powder was suspended and added into 100 ml of distilled water, heated a while and adequate 10 ml into each universal bottle, autoclave and stored well too. For the preparation concentration extract, 1.25%, 5%, and 50% were added into 10 ml of volumetric flask and filled up with 5% of DMSO. Next, inoculation preparation. 2 sterile universal tubes were prepared for inoculate E. coli and B. lecomyformis as in tube A, incubated for 18 hours, and the process was repeated for tube B and tube C. The suspension of tube C was compared to the 0.5 McFarlane standard before using by using UVB spectrometry. Last, this diffusion test. The agar plate were labeled. Each bacterial suspension were taken out using micropipette, swept evenly, and the 6mm paper disc which immersed into each concentration. 5 DMSO and gentamicin were placed onto the agar. The agar plates were incubated for 18 hours and with desert inhibition by the next day. The thick viscous liquid bitter flavor of Elythrine bulbosa ethanolic extract successfully able to yield out 2.22% from the maceration extraction process. For preliminary phytochemical analysis, all of the biological compounds starting from flavonoid, alkaloid, tannins, and saponin were produced as positive results. Based on the antioxidant results in table, DPH was proportionally towards bulbosa extract and ascorbic acid, and both of the sample of percentage inhibition is increased. Thus, it shows that bulbosa able to prevent free radicals formation. The concentration of extract sample is different from standard sample ascorbic acid was due to the strong suppression of antioxidant activity makes the DPPH free radical scavenging assay extremely sensitive, which allow the detect ascorbic acid at low concentration. When the DPPH were mixed up with the extract samples, the color changes from purple to paler due to the caused by a chemical that adds a hydrogen atom to the PPH radical, reducing it to more stable form known as DPPH-H. Based on the both graph, the extract and the standard sample have high correlation values, and it also shows that IC50 of bawang daya extract was lower than the IC50 of ascorbic acid, proving that bawang daya extract does possess stronger antioxidant activity than ascorbic acid. There are some reasons that bulbosa was a natural antioxidant due to the contribution of phytochemical compounds in bulbosa bulbs, which the substance having OH group connected to aromatic ring, able to donate hydrogen atoms to decrease DPPH radical into more stable form, and could do the placement of phenolic hydrogen in phenolic compounds, which affects the ability to scavenge free radical. Antibacterial activity, E. coli act as gram-negative bacteria. B. leconiformis acts as gram-positive bacteria, gentamicin as positive control, and 5% dimethyl as negative control. Based on the table result of inhibition zone E. coli, the concentration of 50% have the higher zone inhibition, which producing intermediate susceptible form, followed by 5% and 1.25%. From this, it proved that the higher the concentration, the bigger of zone inhibition towards the bacteria due to the larger composition of bioactive compounds in E. bubosa. B. leconiformis does not show any zone inhibition towards 3 types of concentration, where in resistant form due to the error in external conditions like contamination and more. The action of secondary metabolic biological compounds were credited with giving E. bubosa extract its antibacterial properties well, such as alkaloid is able to harm the cell wall, tannins able to bind proline-rich proteins and prevent the creation of new proteins. For conclusion, ME process able to yield out 2.22%, while alkaloids, flavonoids, saponins, and tannins were tested positive in phytochemical tests. E. bubosa is a good natural antioxidant and only E. coli able to be as antibacterial agent, while B. leconiformis doesn't due to some error. Hence, the biocompounds in E. bubosa were most contributed in each activity and task. For the recommendations, the other parts of the bawang diet should be more worth to study in future and to try to carry out other pharmacological tests like anti-inflammatory or develop cosmetic products. Lastly, bawang diet extract could be tested with other bacteria like Ascaris for future outcome and research in MIC and MBC tests.